All right, so this lesson is going to be a 2-day lesson, and we're finally starting Unit 2 after many, many months. So Unit 2 is about a lot of different things, but the first thing we're going to talk about are sequences. Then we're going to talk about exponential functions, and then we're going to talk about logarithmic functions. So it also has a whole lot in it. It will go into second semester, so there's quite a bit jammed into these units. So anyway, this first lesson is on arithmetic and geometric sequences. Today we're going to talk about arithmetic, and then Monday we'll talk about geometric. So first you need to know what a sequence is. So a sequence is a function from the whole numbers, which means that's the input, that's the domain. You put in whole numbers into the function, and then to the real numbers, which is the output or the range. So what's not a real number? Pi is actually a real number, 3.14. Negatives are real numbers? Imaginary numbers are not real numbers. You guys don't have a ton of experience with imaginary, just the way that Algebra 2 worked out last year. But when you put something in, you're always going to get a real number out of a sequence. And what's a whole number? One's a whole number. What's not a whole number, I should say? Decimals. Decimals. What else is not fractions? What else? Imaginary. Something else. What about negative? Are negatives whole numbers? No. So the whole numbers start with 0, and then they increase by 1 each time. So those are what you're going to put in, and then you'll get out a real number. So as a result, when we graph a sequence, you just have like a set of points. You do not connect the points. There's no value in between the 2 points like there is with other types of functions. Okay, so on example 1, we have this sequence. This is an arithmetic sequence. I need y'all to pay attention. Arithmetic sequences are typically labeled with A, and geometric sequences are typically labeled with G. So we'll have all these A's today. And instead of f of x, you have A sub n. And so we are going to find A sub 1, which means we're going to plug 1 in for n. So when we do, we are going to get 1. So that means that 1 is the first term in the sequence. A sub 1 is always the first term. All right, we're also going to find A sub 7. A sub 7 is the 7th term in the sequence. So we're going to plug 7 in for n. And 28 minus 3 is 25. That's the 7th term. All right, so in this course, we're going to study 2 types of sequences, arithmetic and geometric. I kind of already said that. Today, the focus is on the arithmetic, and so some properties of successive terms. Successive terms have a common difference or a constant rate of change. What does that sound like we've been talking about for other types of functions? There's a linear. So arithmetic sequences are going to act a lot like linear functions, and the common difference is basically the slope. All right, and so we have a couple different ways we can represent them. This is one way. It's actually my least favorite way. It's just not very helpful because you start with something that isn't technically like considered a term. There's not like a 0th term. So when you use this formula, that A sub 0 is called the initial value. And D is the common difference. So it looks a lot like slope-intercept form. And I probably told you I don't really like slope-intercept form either. It's just not that helpful, but that's okay. It's helpful if you want to graph, but that's the only time it's helpful. All right, the other one I definitely like better. So this one, you can use any term in the sequence and the common difference to write the equation. What does it look like that we may have just used on the test that you took this week? It looks like the secant line equation is the same. You just don't connect the points if you did the graph. So a sub k is called the kth term. That sounds weird. Right. And then some notes are that arithmetic sequences behave like linear functions, except they are not continuous. You do not connect the points. And increasing arithmetic sequences increase equally each step, or basically the slope stays the same, just like a linear function. So let's talk about finding D. So because the common difference is basically the slope, if you have two terms that aren't like right beside each other, you can find them. Find the common difference just basically by doing the slope formula. So I just decided I was going to use K and M as my whatever term it is. So in the numerator, we're going to subtract a sub k minus a sub m. What would I subtract in the denominator? Yeah, k minus m. Very good. All right. So on this first example, we're just going to find a few terms of the sequence and do a little graph. So because I'm only going up to 8 on this vertical axis, we're really only going to be able to plug in 0, 1, and 2. So when I plug in 0, it's just going to be 1. Here's my sequence over here. When I plug in 1, I'm going to get 4. And when I plug in 2, I'm going to get 7. So to do the graph, you just graph those 3 points, and that's all we can do. They should line up linearly, but we don't connect them. Now, something that you are going to have to be able to do is look at a sequence in different forms and determine if it is arithmetic. So that's what we're going to do on example 2. So when it's in equation form, I would typically go back to the ways that you can represent an arithmetic sequence. So this way or this way. It's going to have to look similar to a linear function. So if I have n squared, is there any way that is going to be arithmetic? No. So we can just say no and move on. What about b? Is that going to be arithmetic? Does it look like one of these two? It definitely looks like the first one. So it's going to be yes. And what would d equal?
2.
Close. Super close.
-2.
No. -2, yeah. All right. And then C and D, we have the terms of the sequence, and we have to decide. And so it's similar to when we were deciding, looking at a table of values, if it was linear, by finding the differences, the first differences. That's what you're doing. Taking one and subtracting the first. Taking one and subtracting the previous one, or figuring out how much each has increased. And so that is an increase by 5. Whoops. 5, 5, 5. All right, so this one is yes. And whatever they're increasing, that is your common difference. So on D, if your terms alternate from positive to negative, there's no way it can be arithmetic. You could actually find it and tell that that's going down by 3 and then that's going up by 5. So this is no. Geometric sequences can alternate positive to negative, but arithmetic, there's no way that can happen. All right, so on the back, we have, for example, 3. We're going to say that this is an arithmetic sequence, and we know the third term, and we know the common difference. We're going to write an expression for a sub n, and then we're going to use it. So just real quick, I'm going to write the useful formula in this case up at the top of the page, just so we don't have to flip back and forth a bunch of times. Okay, so the first thing we're going to do is find an expression for a sub n. All right, and these are the things I know. So what do you think I would put in the place of a sub k? We have choices. We have this 3, we have this 8, and we have this negative 3. So a sub k is actually going to be the term, which is 8. And then we'll put in negative 3. N is going to be your variable in this case. And then what about k? 3, because it's the third term. All right, so that is our formula. That is not the only formula. So I don't think there are any sequences on the free response part of the exam. Don't think. There possibly might put one on number 1. I don't think there's going to be. So these will definitely be multiple choice questions. And so when you guys look at my answers that I posted, I'll show you. There are going to be multiple answers for every problem because there are many ways to represent these. So if you're doing the multiple choice test and your answer choice isn't there, it's possible you have to use the other point, or it's possible you have to distribute and then combine like terms. So just be careful on that. I cannot see the multiple choice questions on the tests that you take, so I really don't know. I see some practice tests that they put out, but I don't know what it's going to look like. And you can't talk to me about it, so I'll never know. Just try to prepare you as best I can. All right, so that is one of the expressions for a sub n, not the only one. But we can use it to find the 12th term by just now taking 12 and putting it in for n. All right, and then 8 minus 27 is going to be negative 19. Okay, so I want you today to try and do as much as you can without a calculator. These questions could be on the calculator or non-calculator part of the exam. So if you can do it, then just go ahead and do it. You do have some on your assignment that you get these fractions that don't turn out really pretty. So I don't want you to stress out and get super frustrated. But if you can do the fractions without a calculator, that's good. All right, so example 4, we still have an arithmetic sequence, a sub n. This time, we know the second term, and we know the 6th term, and we want to find an expression for a sub n, and then we're going to use it to find the 24th term. Okay, what do I need to find first? What do you guys think? I need to find the common difference. And to do that, I'm just going to do the slope formula, basically. In the numerator, I'm going to subtract 9 minus 7. And then in the denominator, I'm going to subtract 6 minus 2. Okay. And then at this point, you have options. You can use this first point where you would plug in 2 and 7, or you could plug in 6 and 9 Since what I did when I was working out the answer key to your assignment, if I'm finding the 24th term, I typically just use the bigger term because then there's smaller numbers that you have to work with, but it kind of evens out. But I'm just going to go ahead and use the 6 and the 9. So what would I write first, the 6 or the 9? The 9. And then we're going to add the common difference, and then it's going to be n minus 6. Okay, that is one of the expressions, not the only one. All right, then I'm going to plug in 24. All right, so it looks like we're going to get 9 plus 9. Or 18 for the 24th term. All right, and then for the very last question, we have the graph of a sequence, and we're pretty much going to do the same thing. We are going to write an expression for a sub n, and then we're going to use it to find the 17th term. All right, so there are 5 different points that are graphed here. There could be 5 different expressions. So I want you guys to just pick one of the points and write your expression. I'm going to write all of them. You don't have to. I'm going to write all of them, and then you guys just check to make sure yours is there. So just pick one of the 5 points and write your expression for a sub n. Oh, sorry, I meant to do this first. So when you have the points to find the common difference, you can just count. So as we go from one point to the next, you go down to right 1. So that common difference is -2. Or you could always do the slope formula, but I think it's a little easier if you just count. Alright, so double check that one of these was what you chose. If you have a 0, you technically don't need either one of the zeros, so it's up to you. And then if yours is up there, use yours to find the 17th term, please. What did you guys get for the 17th term? You're still getting it? Just pick one. Plug 17 in for n. It's negative.
-26.
Yeah. All right, y'all get that? Sweet. Okay, so I'm gonna go ahead and give you your assignment.